the ground still shaking. Water seeps through the doors that are miles off the coast, and flames crackle down the sides of buildings. Sirens and screams can be heard throughout the air, yet there seems to be a deafening silence that lurks among the rubble. This was the case through large areas of Japan on March 11th around 3 o'clock in the afternoon after the earthquakes and tsunamis struck. As a student in a natural disasters class at Pitt, I've had the opportunity to do a lot of research on this particular subject, which happened to correlate perfectly with the unit that we were doing on earthquakes and tsunamis. My professor, in fact, has been able to do a lot of on-site work with these types of disasters, so he's been able to give us a lot of interesting information that I'd like to share with you today. I would like to talk to you about earthquakes and tsunamis, their dangers and mitigation efforts, and the relevance that they have today, as seen in the case of Japan. So I'd like to start with a brief explanation of how earthquakes form. On the most easy to understand level, earthquakes happen due to plate tectonic movement, or when the plates of Earth's crust shift. So just on a very general level, there are two types of Earth's crust, being continental and oceanic. And though the oceanic crust is actually much thinner than the continental crust, it's much denser, so it slides beneath this plate in a motion similar to that. And this is known as a convergent plate boundary. This is what happened in the case of Japan, and these are really dangerous because there's a lot of deep focus earthquakes here as the plate shifts underneath. However, there's also divergent plate boundaries, and this is when the plates are moving away from one another. So there's not really a lot of tension here, and therefore there's not a lot of earthquakes. However, there also are a lot of earthquakes at transform plate boundaries. Now, this is where the plates are sliding past one another. So you get a lot of shallow focus earthquakes, and some examples of this could be in Haiti, as we just saw a couple years ago, and also more well known is the San Andreas Fault. Now, whenever these large earthquakes happen underwater, they create what are called tsunamis. Now, unlike tidal waves, which are caused by the wind, tsunamis form when earthquakes happen deep under the Earth's oceans, and then the displaced water comes rushing towards the shore. Now, out in the ocean, a tsunami wave is actually only about a foot high. However, it's about 3,000 feet in length, and it moves in speeds up to 700 miles per hour. So they're extremely devastating as they move closer to the shore because they actually start to grow in height as they suck the water from the shore out into them in a process called shoaling. Now, by the time this wave reaches the shore, it can be up to 100 feet in height, and it completely wipes out forestation and those people in its path. Now, let's look at why these are such dangerous disasters. So, starting with earthquakes, they can be really dangerous because there's not a lot of warning. Unlike natural disasters such as volcanoes, which give a lot of precursors, earthquakes happen without a lot of warning. In fact, in a PBS video, a seismologist actually states that even if there was warning, there's not a lot we could do because it's not in fact the earthquakes that kill people, but the buildings that do. This is because a lot of infrastructures and buildings simply can't withstand all the different wavelengths that are sent through the ground during the process of an earthquake. They move in rotating particle motions, up and down motions, and side-to-side motions. And at the end of the day, a lot of roofing structures and building structures just can't withstand this. Unlike earthquakes, however, tsunamis actually do give a lot of warning time, depending how far they happen off the coast. If they happen really close, they can be extremely dangerous, as seen within the case of Japan. However, if they happen farther off the coast, people can have a lot of warning time, so they can move to higher ground and evacuate the coastline area. However, as I mentioned, when they do happen close, in the process called shoaling, a lot of people, as I mentioned earlier, will come down to see the ocean being sucked away, and then when the tidal wave comes in, it's extremely dangerous, and that was seen in South Asia in 2004 and caused a lot of deaths. So, as you've probably realized in the news recently, it's completely relevant to know a little bit about earthquakes and tsunamis, just because understanding them can really give you a little bit of relevancy in what's happening in the world today. And although small earthquakes and tsunamis happen on a very often and frequent basis, large ones happen worldwide every couple of years that can be truly devastating. It's also important to know a little bit about these disasters because it's becoming more relevant in the world today. Although there's no scientific evidence that the number of natural disasters have increased over the past couple of years, the amount of deaths and insured losses have gone up dramatically just because property is becoming more expensive and more commonly located along the coast. In addition to this, it's estimated that by 2025, the world's population will live about 2/3% in cities, 40% of these being located coastally and in extreme susceptibility to earthquakes and tsunamis. So, as you've heard today, earthquakes and tsunamis are really important to learn about, and you've learned about their causes, their dangers, and why it's important to know a little bit about them. So, although it can be extremely devastating for people, geohazards are fascinating to explore and to understand. So now, if you're ever visiting a city and you see the water being sucked away from the shore, or you feel the ground start to shake, you know what's coming your way.